let me repeat again here. So this the first command is to just to create our data set. So whatever we have considered the example, first you have to write that example in terms of observations, because that is given in terms of frequency. It's a frequency distribution table. Okay, so we have the families, male, we have the families which is your frequency, we have the male. So 0 to 12, so we have to create a sequence from 0 to 12, each increased by 1. So this will give you the basically number of males are there in your problem. Similarly, this is the frequency. So each family. So frequency is basically your family. So this is your families. In each family, how many males are there? So like in the first 3 family, we have 0 male. Next 24 families, we have 1 male, and so on. So you are repeating this Y with frequency. So this will give you the basically total number of observations which are there in your entire data set. You can cross check this also. So we know that in our data set we have a total 6155 families. We have already seen the examples maybe in the previous lectures. So total number of families we have 6155. So this is matching. That means our data which we have entered in R, which is absolutely correct. Okay, so even if there's some mistake, maybe by mistake you have written maybe 0133 or 1432. So if you just calculate the total number of observations, it will not match. So you have to cross check your frequencies properly. Accordingly, you can change your and x and frequency, and then run it again, and you will be get this number of total number of families. So this will, I will just write down your total number of let me know if you are, if anybody getting the problem. So let me know total number of families. Okay, which is coming. Yeah. So now we have maximum number. So this is the number of children's number of male children, you can write male child, you can say. Okay. It is a maximum can be. Okay, now so I got the many answers here. Like your first round movement, Devang is saying 6.23, and the second round movement is 42.30. So let us just compute this. So now you have very simple data. आपके पास x data दिया है और आपको निकालना है mean. So it's very simple. You add up all observations. That means मेरा x का जो data है, that is my simple observations, है ना? And I want a mean. तो mean कैसे निकालोगे? Sum of your observations divided by total number, which is capital. This will give you the basically first round movement. Let's run it and see. Yeah, now you can observe my first round movement. So this is my first round movement. This is my first round movement, which is coming 6.2305, which was matching with Devang answer, Vedang answer. And this is my second movements. Okay, so let's check it with second round movement, which is 42.309. So absolutely it's correct. So that has been both the answers correct here. Aishwarya, just check your answers. There is slightly change in your answer. I don't know why it is coming like 0.05 ka difference, 0.5 ka difference are I don't know. Might be you have not entered this frequencies properly. Just cross check 1 second so that you might get clear answers with this. Are you, are you doing manually or you are doing with the help of RStudio? Actually,
Manually, sir.
manually might be some problem with your data set. But answers are very near. Okay, answers are very near. So now once we get the raw moments, we have already estimated the value of A and B using method of moments. This is using method of moment. So we have already estimated using the method of moments. So A and B can be easily calculated using that method. So I have already given the expressions. We need to work little on that expressions which we struggled yesterday's class and to get these derivations. I think this is not a right screen. Let me just open the right screen here. I just want to show you how this. So this was our alpha, this was our beta. So we have to write the code in this way only, m1 time n into m1 minus m2 divided by n time m2 m1 square m1 plus m1 square. So this way you have to write the code. Okay, so you can just follow this m1 m2 n and write down in terms of in RStudio. You can just cross check whether this is right or wrong. Okay, so I have already shared this last class notes here, so you can just open and just check whether this code which is written here A and B which is same. Because we have to take it be carefully, because of if you just write m1 m2 or m2 m1, it will little confusing though it's all wrong. So have to be take care properly related to this. So you can calculate this and you can calculate this one also. So this is your alpha, this is your beta. So alpha is coming here 34.13 and beta is coming here 31.60. So these two values are calculated within a moment, within a minute. Whereas when you do the manually, you can understand how much time it is going to be take, even if you do it with the help of calculator. So RStudio is like very excellent platform where you can uh, run and you can get your answers very easily. Okay, so till here, any question, anyone? Have you understood all the steps and all?
Yes, sir.
Other students, at least you can interact via chat box. That is also fine. There will be no harm if you're saying yes or no, or not getting, or not understanding, or repeat, or pardon. But if you just keep quiet, then I'm so tired. So I feel what is going on? Something is going. There has to be something, right? Okay, we have responded, no problem. So this is the way we can have the initial value. So once we have the initial value now, what is the next task? You got the value of A, we got the value of B. A, B was it's alpha, beta. So we have got alpha and beta. Now we have to use our likelihood functions. Okay, so I'll just share the screen for the likelihood function first, because we have to understand that function. So look at the MLE we have, which we have discussed yesterday's class. So first, this is my function. This is my function, right? So we have MCXR beta, that is a beta function x plus alpha plus xi comma beta plus m minus xi divided by beta alpha plus beta. Okay, so based on this we have obtained the likelihood functions. Okay, so this is the uh, n time log of your gamma functions minus log of alpha log of beta. Okay, so I have to write this function first. Instead of writing function, if because we are going to write the Newton-Raphson method, where if you just observe, we don't require actually language. But if you want, you can write down. Otherwise, you can write down the derivative because we require a derivative. Okay, so that's why we have obtained alpha, beta, alpha square, beta square, and alpha beta. So these 5 derivatives we need to be get always when you are using the Newton-Raphson method. Okay, so I'm going to put this in terms of R studio. Let's look at this. So this is my beta function. This is my beta function. So I'm just creating your functions. So choose nx. Okay, we have written mcx, right? Into beta x plus alpha minus n minus x plus beta divided by beta that is sorry, beta function alpha comma beta, right? This is my actual beta function. This is right. If you have your previous class notes, you can open it, you can check whether this function is how this function is written. Now look at what I'm going to do here. Now if you, so this is your beta binomial function. Okay, so beta binomial function will be this. Now what I'm going to do, I'm going to compute the function at the value a and b. Okay, because this is my initial values of my a and b. Okay, so let's run this again, and this is just additional I have written here. So if you want, you can do, otherwise you can leave it. So I have just obtained the probability of my beta binomial function at these two values, which I have already computed. Okay, you can look at the plot also. Look at the plot. So what you can observe here, it's look like a normal, but here this is a more spread as compared to the binomial distribution. Because we have observed the binomial distribution, where in the binomial distribution the tails are not more spread, but whereas your beta binomial having the tails are more spread. Getting the point? So that's the one difference you can observe while estimating the parameter. Okay, you can try to fit the plot, temporary plot. We just see the plot. So observe that. Again, it's a type of histogram. So this I have plotted, I guess, all the data with this line. So these lines are actually your fitted lines, and this is actually your data. Okay. This histogram was your actual data, and this is your actual fitted data. So like we have maybe in the previous classes we have seen the how the exponential Weber distribution fit to my data set. So this is the way you can fit the data. So if you just observe both this curve and as well as this histogram, both are almost matching. So one can check the using the Kolmogorov similar test also. But here again the problem is that if you are using the goodness of it, then we require PDF CDF. So PDF you have, but CDF is difficult because you will be at the incomplete CDF. Okay. So that's a things you can always observe from the problem itself. Okay, but you can observe clearly from the this particular graph that the fitted fitted data set and this actual data set both are almost fitting my curve. Okay, is that clear till here, or any steps which you not understood? Okay, now let us look for the derivative parts, means MLE part. So what I did, I have already computed the MLEs, that is the likelihood equations for alpha, for beta, then the second derivative of alpha, second derivative, that means second derivative of likelihood function with respect to alpha, with respect to beta, and then with respect to their covariance, that is alpha and beta. Okay, so we need to define again function. We need to define again function. Just a minute, students. Okay, so we have to again write down that partial derivatives in terms of function only. Okay, so you may observe the problem will not be same. Okay, will not be same. You may work for the different example also. ठीक है, but आपको टेक्निक समझ में आना चाहिए. You should learn technique. Okay, problem can be differ. Okay, so here I have considered the beta binomial. You can consider any you may consider binomial distribution, you may consider exponential, you may consider normal distributions. Okay, so normal distributions में again we have two parameters. तो आपको म्यू का निकालना पड़ेगा, सिग्मा का निकालना पड़ेगा, फिर इसका सेकंड डेरिवेटिव निकालना पड़ेगा, थर्ड. बट अभी वो सिचुएशन में क्या होता है, MLE will be easy to obtain because MLE in the case of binomial and all it is very easy, right? There will be no iterative procedure is required. But if you want, you can work with iterative procedure and you can just check कि answers आपको iterative procedure से और इससे दोनों same मिल रहा है. Ideally we will get the same answers. Okay, but here we have to apply iterative. तो अगर मेरे पास ऐसा कुछ function है where I is running from 1 to something, so how we can code it, how it is work in your art studio. Okay, तो इसको ये way में लिखना पड़ेगा. So we have the function with terms of a and b because we have alpha and beta. Then we have written there n into xi naught. So xi naught is our basically the digamma function. Xi naught is basically a digamma function, and trigamma function is your xi1. Okay, I think we have used the same notations if I'm not wrong. Yeah. So the second derivative will be your xi1 will be your trigamma function. I have written somewhere here. Here, look at here. Xi0 will be a digamma function and xi1 will be a trigamma functions. Okay, so we have to use these codes in terms of zygamma and trigamma. Okay, it's very important. Okay, so obviously the first derivative में सब आपको digamma function ही मिला. Okay, so digamma a plus b minus digamma of a, digamma of a plus b and plus sum, because we have the summation I is running from 1 to, and I'm just changing my screen in both the way because we have to just compare whether it is right or wrong. So we have the digamma function in sum with x alpha plus xi. Okay, so we have alpha plus xi and we have a sum. So I have to use command here. What is that? It is sum digamma function alpha plus x. Okay, so it should match. It should match with your the likelihood equations. Okay, so this is with my alpha, or you can say with respect to a, we have assumed a is your alpha. Then we have a second derivative. We have used a means second derivative. Okay, a is first derivative, a is second derivative. So obviously it is going to be same जहाँ पे डायगामा फंक्शन और फिर ट्राइगामा आएगा, बिकॉज अदर थिंग विल बी गोइंग टू सेम ना, बिकॉज डायगामा को ही आप डिफरेंशिएट कर. ओके, so it's going to be trigamma. So जहाँ पे digamma है, you replace by trigamma, everything is going to be the same. Okay, there will be no change in this derivative part. Okay, similarly you can do it for b, that is your beta. So beta के लिए भी आपको same use करना है. सब कुछ सेम रहेगा, जहाँ पे डायगामा ए है वहाँ पे बी आएगा एक्सप्रेशंस में, बिकॉज आपका जो बिकॉज वी हैव सेपरेटेड अल्फा बीटा है, तो बीटा से डेरिवेटिव करेंगे तो अल्फा जीरो होगा, अल्फा से डेरिवेटिव करेंगे तो बीटा जीरो होगा. तो ये सिचुएशन में इसीलिए यहाँ पे we didn't get the beta term here. Okay, similarly अगर आप बीटा से कर रहे हैं then you will not get the alpha cut. The rest is going to be the same. Okay, so you can just look at the expression. Once you understood this one, it's very easy to for rest you can do. So we have the beta, we have the beta binomial. We have double derivative here, and then we have a with respect to AB. Whether you say AB or whether you say BA, both will give the same thing. Covariance between XY or covariance between YX will give you the same results. Okay, so this you can work. So in this way you can create a first partial derivative. Okay, you can create the partial derivative. So let me just run each of these derivatives here. Okay, and now I have used my MOM as the initial estimates, which we have already discussed, because estimating the parameter of MLE, we require the initial value which we have already computed using the method of moments. So this will give you the, ideally it is same, which is 31 or 34 approximate. Now here we are creating the iterative procedure, which is your Newton-Raphson method. Okay, so this is the important part which you have to understand. Okay, so now I'm doing this iteration maybe 5,000 times. Okay, so for I in, I'm just doing the simulation 5,000 times, 5,000 times with my parameter. What are the parameter we have? We have a two parameter, that is A2, B2. Okay, now here I have used the parameter is my A2, B2, but this is your alpha beta. Yeah, this is because I cannot use A and B again here, because A or B तो आपका हो गया है ना. This you have used for what is that, for moments. So you cannot use the same parameter for MLE also. So here I have used the parameter A2 B2 is means A2 B2 is my actual initial values, and these two are my parameter. So I am creating here one matrix A2 B2 which contain number of rows are 2. So we have 2 rows, that is A2 and B2, this one. Okay, so this is my parameter, and we have the FD, that is your first derivative. This is your score function which I've discussed ना. Score function बोलो या फिर first derivative बोलो. तो score function क्या था आपका? It is your first derivative of your likelihood function, right? तो first derivative क्या है आपका? Double L dot A, double L dot B, correct? That was your first derivative. तो first derivative में आपको A2 का वैल्यू सब्स्टिट्यूट कर, इनिशियल वैल्यू सब्स्टिट्यूट करना पड़ेगा ना आपको. सो डबल डेरिवेटिव में, सॉरी सिंगल डेरिवेटिव में, दैट इज द फर्स्ट डेरिवेटिव में A2 का वैल्यू बीटा का वैल्यू सब्स्टिट्यूट करो. सिमिलरली बीटा में A2 का वैल्यू सब्स्टिट्यूट करो, बीटा का वैल्यू सब्स्टिट्यूट करो, और नंबर ऑफ रोज कितना है? सेम ही रहेगा, 2 ही रोज रहेगा, राइट? सो दिस विल गिव अ स्कोर फंक्शन. I don't know whether you are understanding or not, but it is very easy to explain with the help of this theory. अभी मैंने अल्फा बीटा निकाला. सो अल्फा बीटा निकालने के बाद में अगर मुझे एमएलई का अल्फा बीटा निकालना है तो मैं क्या करूंगा, मैं इसमें अल्फा बीटा का वैल्यू मुझे मिल गया, करेक्ट, आई विल सब्स्टिट्यूट हियर, तो इससे मुझे एक इक्वेशन मिलेगा। सिमिलरली इसमें सब्स्टिट्यूट करूंगा तो इससे मुझे इक्वेशंस मिलेगा। तो सेम थिंग आई हैव कोडेड इन टर्म्स ऑफ आर। तो ये मेरा कैसा हो गया, ये मेरा फर्स्ट रो हो गया, मेरा सेकंड रो हो गया। सो नाउ आई एम क्रिएटिंग अ मैट्रिक्स विथ दिस फंक्शन comma this function comma number of rows is equal to, okay, that is your first step. सेकेंड स्टेप क्या था आपका, दिस इज स्कोर फंक्शन, तो मैंने स्कोर फंक्शन लिख लिया, दिस माय फर्स्ट डेरिवेटिव। देन आई नीड टू क्रिएट अ जे, जे विल बी व्हाट इज दिस जे, जे विल बी योर 2 क्रॉस 2 मैट्रिक्स, करेक्ट। इसमें क्या क्या आएगा, सेकेंड डेरिवेटिव आएगा, क्रॉस प्रोडक्ट टर्म आएगा, और मींस अल्फा का आएगा, सेकेंड डेरिवेटिव ऑफ योर, यू कैन से सेकेंड डेरिवेटिव विद रिस्पेक्ट टू अल्फा, सेकेंड विद रिस्पेक्ट टू बीटा एंड देयर क्रॉस प्रोडक्ट। तो इसमें कितना मैट्रिक्स मुझे मिलेगा, 2 क्रॉस 2, करेक्ट। सो जे मैट्रिक्स बनाना है जिसमें आपको 4 एलिमेंट्स लिखना है और नंबर ऑफ कॉलम 2, नंबर ऑफ रोज आर 2। सो नाउ लेट अस लुक एट द कोड। सो जे फंक्शन बनाया हमने। नाउ आई विल टेल यू व्हाई वी हैव सॉल्व हियर। मैट्रिक्स बनाया है C, because you're creating more than one vector here. डबल ए मतलब डबल ए मतलब सेकंड डेरिवेटिव, सो डबल ए पे a2 b2 निकाला। then we have the product term, second element, remember, alpha beta. Then third element, you can use same because it is same na, so you can use again this, you can take it copy, and then we have a beta beta. Then number of rows are 2, number of columns are 2, तो आपको एक 2 cross 2 matrix मिलेगा। so J will give you the 2 cross 2 matrix. And why we have used solve here, look at the solve, why we are using solve here, because here we have J inverse. तो J inverse कैसे निकालते हो आप लोग, J inverse
Solve.
अगर आपको, exactly, so we have to use the command solve, so this will give you the J. so J inverse आपको मिल गया, और जैसे J inverse मिला आपको, आपको पैरामीटर एस्टिमेट करना, तो पैरामीटर इज इक्वल टू पैरामीटर which is your, look at this, कैसे निकालना पैरामीटर, पैरामीटर इज इक्वल टू पैरामीटर माइनस J इनवर्स इनटू फर्स्ट डेरिवेटिव, द स्कोर फंक्शन। तो मुझे यहाँ पे कोड के टर्म में लिखना है। सो दिस इज पैरामीटर, this is your initial parameter minus J, and you want to do product, and this is the matrix product. So whenever you have matrix product, we have to use $sign I into the product sign between that. So it's a dollar, sorry, it's percentage into percentage. So this will give you the product of a matrix, and then you can store those values. A2 will be in the parameter 1, that is your first one, that is your first row of the first column, and B2 will be the second row of the first column. So this will give you the basically the values of A and B. So this is the entire iterative procedure to compute and find B2. इसको एक बार go through करो आप, understand करो, कुछ query है तो मुझे बोलो, okay? Because it will take little time to understand it. केवल आपको प्रोसीजर जो थियोरेटिकल मैंने प्रोसीजर दिया पहले आप उसको समझो, उसमें क्या क्या टर्म्स निकाले हैं, वो एग्जैक्टली सेम वे वी आर गोइंग। अगर आप थियरी फॉलो करोगे तो इट इज वेरी इजी टू राइट द कोड एंड ऑल। सो पहले इक्वेशंस लिखा, पहले लाइक्लीहुड फंक्शंस लिखा, तो लाइक्लीहुड फंक्शन हमने लिखा हुआ है। देन हमने इक्वेशंस लिखा, तो वी हैव रिटन 5 फंक्शंस, देन वी हैव रिटन स्कोर फंक्शन, देन वी हैव रिटन जे, देन वी हैव सॉल्व, ओके, exactly same way I'm going in terms of my art. कितना आप समझ पा रहे हो, आई डोंट। Can you